In this, we are seeing about single phase multi-level inverter topologies with self voltage balancing capabilities, which is used to drive the induction motor. Okay, we are using a single phase multi-level inverter topology with self voltage balancing capability in order to drive the induction motor. First, we will see about the inverter topology. Here, a voltage of 110 volt and two sources. Second source voltage of 110 volt. So this is symmetrical multi-level inverter. In this, we are using one capacitor here. The capacitor value is 1 millifarad and the capacitor voltage, it is mentioned as 50 volt. Okay. And in this, if you see, this is the capacitor voltage and current. The capacitor voltage, it is around 50 volt. And the capacitor current, here initially it was charging and then it is discharging. Again it is charging and again it is discharging. Similarly for negative cycle. So for one cycle, it is 4 times charging and 4 times discharging. And the voltage is maintained as stable. Here we are using 1, 2, 3, 4, 5 switches plus a setup of one diode bridge with a bidirectional switch. This switch will conduct in bidirectional. So totally 7 switches we are using for 9-level inverter with 2 sources and 1 capacitor. These are the pulses generated for each switches. Totally 7 switches are there. So 7 set of pulses are used here. And for one cycle, this is the pulse for one cycle for S1, S2, S3, S4, S5, S6, S7. And these are the output voltage and current. In this, if you see 1, 2, 3, 4, 5, 6, 7, 8, 9 levels we are getting. And the voltage is around 220 volt. So whatever input we are providing, output we got it. This is symmetrical. Next one we can see about asymmetrical. In this 165 I have provided at the right hand side, left hand side 110. That means this is 2 times, this is 3 times, or 1.5 times of the left hand side. Left hand side capacitor, same here, 1 millifarad, 55 volt, and here 82.5. In this, if you see the capacitor voltages, okay, it is around 55 volt we are getting, and the capacitor is charging and discharging for each cycle. Similarly, at right hand side, the capacitor voltage is around 82 volt, and here it is charging and discharging. And these are the load voltages. Okay, these are the load voltages. Level 1, level 2, level 3, level 4, level 5, level 6, level 7, level 8, level 9. It is around 280 we are getting. So 165 plus 110, nearly 270, 280 we will get as the sum of the voltages. So for asymmetrical voltage also, we are getting the output 9 levels. Then instead of this R load, here we are using an R load of 65 ohms. We will connect one induction motor, and to control the speed of the induction motor, we will use boost converters. Here if you see, the two sources is replaced with battery with boost converters. That will be provided in the ratio here. That is, this is speed control loop and these are voltage control loop. Here the input voltage is around 12 volt 15 Ah. Similarly here also 12 volt 15 Ah. So two batteries we are using, that we are giving it here. According to the speed reference, we can get the output voltage level of the boost converter. Here the boost converter voltage is initially 40 and after 0.75 seconds it is increased to 160. That is boost converter 1 voltage is around 120. Boost converter 2 voltage is around 160. And here this is the speed. Okay, the speed is increased and it is settled around 155 or 156 radian per second. That is given here as RPM. Here for controller, we are providing feedback through this gain. This gain will convert the radian per second to RPM. According to that, we will get the DC voltage reference. And here DC voltage is measured across the boost converters and taken as feedback. And that is given to PI controller. The PI controller will generate duty ratio for the respective boost converter and pulses will generate separately. And it is given to the output of the boost converter is given to the multi-level inverter, and output of the multi-level inverter is given to the single phase asynchronous motor. And here the output of the multi-level inverter connected to the motor is provided here. Depending upon the motor speed settling time, here the voltage is varying. Until it's settled, the voltage is less. After it's settled, the voltage increases. This is the working, that is the working of the boost converter fed multi-level inverter based induction motor drive control. Induction motor drive control. The speed of the induction motor drive is controlled by the boost converter output voltages. Second is current. Okay, we are getting 5.68% as the THD. Okay, this inverter will work based on both symmetrical and asymmetrical voltages, and also we can provide it to both R and RL loads. And in this, for motor speed control, we are using boost converters. Instead of sources directly connected to the inverter, we are connecting the sources through boost converter to the inverter. Through the boost converter, we can control the voltage, and by controlling the voltage, we can control the speed of the induction motor. Okay.